Good morning all. Today we will discuss about RLC circuit, where the R, L and C all are connected in parallel. So we will discuss about the parallel RLC circuits. Now in parallel RLC circuit, we need to know first, we need to know the parallel circuit, which contains RLC components connected in parallel combination. Now in parallel combination or in parallel circuit, voltage across the elements is same or equal, and number 2 is current may be changed. That depends on the value of impedance created by each elements. So we can draw one simple parallel circuit excited by one alternating current source. So now if we take one example of parallel resistive circuit containing 3 different resistors connected in parallel, so we will get this type of circuit, and we can name it, that is R1 first resistance, second resistor is denoted by R2, and third resistor is denoted by R3, and there may be some other resistors also. So this is parallel resistive circuit. So parallel resistive circuit. Now similarly, using the 3 different components, that is R, L and C, we can develop our parallel RLC circuit. So we can draw like this. So where the resistor, inductor and capacitor all will be present, and they will be connected in parallel to each other. So we can denote this element as R, this is L and this is C. So this is our parallel RLC circuit. Now if the Vs is the supply voltage, so Vs can drive one current which will be Is or It, total current, which will be divided, and it will be sending different amount of current through each element. So we can name it as IR, IL and IC. That means the current which is passing through the resistor is denoted by IR, the current which is passing through the inductor is IL, and the current which is passing through the capacitor, that is IC. Here we know that these currents may be same or may not, depending on the value of impedance created by each element. So the impedance created by R, say ZR, and impedance created by L, say is ZL, and impedance created by C is ZC. And we know that in earlier discussion, ZR equal to R, ZL equal to XL, that is equal to omega L, and ZC equal to XC, that is equal to 1 by omega C. And now, depending on the value of resistance, inductance, capacitance, and also depending on the value of the frequency of the supply, that is say F, if Vs is a function of F, then the amount of current will depend on R, L, C, and omega for a particular Vs. Now, if we have this parallel RLC circuit, we understood that current produced by Vs will be divided in three different branches. The current IT is equal to IR plus IL plus IC. Now what about the voltages across the element? So this is the voltage across resistor. VL is the voltage across inductor, and VC will be the voltage across capacitor. Now here you can see from the circuit that V equal to, that is the voltage across all these elements. If we take, because here you can see that these voltages are constant, so we can write that VR equal to VL equal to VC. So all these voltages are same because they are connected in parallel, but currents will not be same, or it's better to tell that current may be same or may not be same, and it depends on the specific parameters as we have already mentioned. So now if we go for the phasor diagram of the parallel RLC circuit, we need to follow the rule for reference phasor. So in the series RLC circuit, if we recall that the reference phasor was the parameter which was common for all the elements. So in this parallel circuit also, we will take the reference phasor for the parameter which is common for all the elements. As we see, the voltage across the elements are same, so we will take this parameter as the reference phasor. Now, if we don't take this V as reference, then also it is possible to draw the phasor diagram, but if we take that, it will be little bit easier.